Every team builds API and every API has bugs. Today, finding those bugs means writing test cases by hand or pointing a fuzzer at the endpoint and hoping something breaks. What if an agent could do it for you? We built an OpenENV RL environment where an agent learns to test REST APIs the way a security engineer would. Behind the scene is a real task management API with 13 planted bugs mapped to the Ops API security top 10. The whole environment is a single fast API process wrapped in OpenENV standard step, reset and state contract. Reseeded on every reset so the agent can't memorize answers. 13 deterministic detectors that fire when a planted vulnerability is hit, and a reward function plus a per task grader that produces the final score. So here is where it gets interesting. Most RL environments give you one signal at the end, pass or fail. That's not enough to learn from. Every action the agent takes runs through this matter and produces a partial reward. Discovering a planted bug pays off the most, up to 0.25. Hitting a new endpoint, sending a valid request, chaining IDs from prior responses all add to the signal. Repeating yourself or sending malform requests is penalized. Every single is verifiable. No LLM as a judge, no soft heuristics. An episode walks through these states, from idle to stepping to detecting bugs to grading and final a structured ops report. Same lifecycle for every task, only the seed and the difficulty changes. Zoomed in, every step follows the same path. The agent's action becomes an HTTP request. The buggy API hits the database and returns a response. The bug detector checks whether a vulnerability is fired, and the reward engine produces a signal between 0 and 0.5. Repeat that 25 to 45 times and the grader closes the episode with a score in 0 to 1 plus the structured bug report. So here is a live playground. It runs on an HF space and anyone can use it. So on the left I pick a task. Basic validation is the easy one. Let me pick the security workflows. Reset gives me a fresh database with new users and new IDs. And then I run the smart baseline agent. On the right the bug shows up as the agent finds them, each one tagged with its OASP category. Below that, the activity log streams every API call with the status code and the reward earned. And when the episode ends, the bug report drawer fills it with the full OASP assessment, recommendations, and the work. How do you know the reward signal is actually meaningful? We ran 4 different agents through the environment and scored every episode on the same 0 to 1 scale. If you can see on the image, random clocks at 0.32, that's the floor. A sequential agent walking a fixed path gets to 0.56. Smart is 200-line hand-coded heuristics that target each of the 13 bugs by ID. It hits 0.83 on average. And the purple bar is Llama 3.370 billion, a frontier general purpose model runs through our inference.py script with no task-specific code, no scripted heuristics, and no examples, just the API specification and a system prompt. It scores 0.67 on average. If we break it down task by task, on basic validation, Llama scores 0.85, on edge cases 0.65, and the hardest task security workflows 0.58. As the next step, we plan to fine-tune a reasoning model on the environment using GRPO to see how much of a gap between Llama and the smart heuristics a trained agent can actually close. That's the API testing RL environment. The repo is on GitHub, the space is live on Hugging Face, and the links are in the description.